Hello students, welcome to Akash Live. I'm your mathematics faculty and today we're going to discuss the quick solutions of AIATS for JEE Main 2020 test number 3 code CND. Okay, so this test was held on 16th of December 2018. The syllabus for this test covers the topics of binomial theorem, sequences and series and permutations and combinations. Okay, so let us begin the discussion with question number 61 in the portion of mathematics. It says that if XYZ are in AP and YZX are in GP, then what is the value of x plus 4y upon x plus z, where x, y, z are distinct real numbers? Students, if x, y, z are in AP, they can be taken as y minus d, y and y plus d. And if y, z, x are in GP, y, z, x. So in the AP, I have taken all the three terms in terms of y. In the GP, I will also do the same. Y, yr square. Okay, students, what is the scenario now? You can equate the value of x from the first part and second part. You can equate the value of z from the first part and second part. You have two equations and you have two variables. The variables are d, the common difference of the AP, and r, the common ratio of the GP. So we have z from the first equation as y plus d is equal to yr from the second equation, and x from the first equation y minus d is equal to yr square. Let us add both the equations. So you'll get 2y is equal to yr plus yr square. So this will give you r square plus r minus 2 is equals to 0. So this is r plus 2 into r minus 1 equals 0. R cannot be 1 because the numbers are given to be distinct. So r is equal to minus 2. If r is equal to minus 2, the GP is y minus 2y and 4y. So the final answer will be x plus 4y. X is now 4y itself. And then plus 4y divided by x plus z. X is 4y, z is minus 2y. So that means the answer is 8y upon 2y. The answer will be 4. Option number 2 satisfies. So it is a little bit of lengthy question, but if you choose the approach smartly, it will be very easily done. Okay, let us move on to 62. Question number 62 says that if ABC are distinct real numbers such that a into b minus c of x square plus b into c minus a of xy plus c into a minus b of y square can be expressed as a perfect square, then which of the following conditions is true? First condition is of AP, second condition is of GP, third is of HP, and fourth is given AB plus C is equal to A plus BC. Students, let us divide by y square. Let us call this expression as E. Dividing by y square, I will get A into b minus c into x square by y square plus b into c minus a into x upon y plus c into a minus b. If we have divided by y square, we will have to multiply by y square also. So this is y square into a into b minus c of t square, where x upon y is t, b into c minus a of t plus c into a minus b. If this is a quadratic equation in some variable and the question says that it can be expressed as a perfect square, that means the discriminant is 0. So put the condition d is equal to 0, you'll get b square into c minus a whole square minus 4ac into b minus c into a minus b. So all you have to do is you have to simplify this equation. After simplification, you will get 2ac is equal to ab plus bc, which ultimately means that 2 upon b is equal to 1 upon c plus 1 upon a, or the other way around. Option number 3 is the correct choice. Okay, let us move on to next question, that is 63. Question number 63 says that the sum of the series x raised to power n minus 1 plus 1 upon x raised to power n minus 1, 2 into x raised to power n minus 2 plus 1 upon x raised to power n minus 2, so on till n minus 1 into x plus 1 by x plus n. Here it should have been x raised to power 0 plus 1 upon x raised to power 0, that is 1 plus 1, that should be 2, but here is not 2, so we will not include this particular term in the series. What are we going to do? We are going to deal this as two series. S1, the series is x raised to power n minus 1 plus 2 into x raised to power n minus 2 plus 3 into x raised to power n minus 3, so on till n minus 1 into x. Okay, S1 divided by x will be x raised to power n minus 2, 2 into x raised to power n minus 3, and so on till over here I will get n minus 2 into x plus n minus 1. This is the standard procedure by which we deal with the AGP. Subtract them, negative, 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 negative. I'll get S1 minus S1 by x is equal to x raised to the power n minus 1 plus x raised to the power n minus 2, so on till up to x raised to the power 1 plus 1 minus n. Okay, this is a GP now. The GP answer will be x minus 1 upon x into S1 is equal to first term, that is x into r raised to the power n minus 1. So r is x, n is n minus 1 upon x minus 1 plus 1 minus n. From here, what are we going to get? We are going to get S1 is equal to x square x raised to the power n minus 1 minus 1 upon x minus 1 whole square plus 1 minus n into x upon x minus 1. Students, it is very obvious that if you replace x by 1 by x, you'll get the answer of second AGP, that is S2. So S2 can be directly written as 1 upon x square 1 upon x raised to power n minus 1 minus 1 upon 1 upon x minus 1 whole square plus 1 minus n into 1 by x upon 1 by x minus 1. X square will get cancelled. This will be 1 minus x raised to the power n minus 1 upon 1 minus x whole square plus 1 minus n upon 1 minus x. Okay, this is S2. So the final answer of the problem is S1 plus S2 plus n. Students, you'll have to do a little bit of manipulation, and after doing that manipulation, you will get 1 upon x raised to the power n minus 1, x raised to the power n minus 1 upon x minus 1 whole square. Okay, that is the final answer. So let us have a look at the options. Option number 4 is the correct choice. Okay, no doubt this is a lengthy problem, so most of the students can skip it. Okay, let us move on to the next question, that is question number 64. Question number 64 says that let ABC are positive real numbers such that AB plus BC plus C equals 12. Then what is the greatest value of ABC? Students, in this type of question where we see that they are written to be positive real numbers, we directly go for AM-GM inequality. So let us apply AM greater than equal to GM for these set of positive numbers which are AB, BC and CA. So AB plus BC plus CA divided by 3 greater than equal to the product of AB, BC, CA whole raised to the power 1 by 3. This is 12 upon 3, that is 4 whole cube is greater than equal to A square, B square, C square. That means A square, B square, C square is less than equal to 64. We need the maximum value of the product ABC. We can see that ABC will be less than equal to 8. Okay, that means option number 2 is the correct choice. A very, very simple and straightforward application of AM-GM inequality for the set of positive numbers. Okay, let us move on to 65. Question number 65 says that we need the coefficient of x bar 5 in the expansion of 1 plus x divided by 1 minus x if mod x is less than 1. So if mod x is less than 1, I can apply binomial for any index. Coefficient of x bar 5 is required. 1 plus x upon 1 minus x can be written as 1 plus x into 1 minus x raised to the power minus 1. Now applying binomial index, I can say that 1 plus x into, this will be 1 plus nx plus n into n minus 1 by 2 factorial into x square. So simply x square, then x cube and up to so on till infinity. In the other terms, we can see that this infinite GP, if mod x is less than 1, has the sum 1 upon 1 minus x, which is already written above. I need the coefficient of x bar 5. Obviously, the next term here will be x bar 5 only, plus the next term will be there. Coefficient of x bar 5. When 1 will be multiplied by x bar 5, then we'll get coefficient as 1. And when this x will be multiplied by x bar 4, then again one more thing that we'll get here is 1. So coefficient of x bar 5 comes out to be equal to 2. We have option number 3 as the correct choice. Again, a simple question. given that you know the concept of binomial for any index. Okay, let us move on to 66.